Hi everyone, it's nice to meet you if I haven't met you before, and if I have, it's very nice to see you again. Welcome to Intermediate Algebra, Math 98. Our first video here is about reviewing over some basic Math 96, the previous course concepts here, so we can get ready for some of the other things that we need to talk about. So we have a quote here from Thomas Mann, a German novelist, who says, "Order and simplification are the first steps towards the mastery of a subject." And that's part of what we're going to talk about today. So Basic Algebra Review Part 1, by the end of this review, you should be able to identify number groups and perform operations on real numbers, identify linear equations and solve, simplify expressions by combining like terms, simplify exponential expressions, and divide polynomials. So there's a bunch of different number groups that we're going to talk about, and this is from Chapter 1 in our textbook, Real Numbers and Their Operations. So natural numbers are those numbers that you naturally learn first when you're very young. So we teach our kids how to count. We start with 1, 2, 3, 4, and we keep going up infinitely. We could keep counting, so we're going to use a dot, dot, dot to represent that pattern keeps going forever. So the next number that we add on, we start talking about 0. So if you have all of those natural numbers and you add 0 to those, that represents all of the whole numbers. So whole numbers are 0, 1, 2, 3, 4, keep going, etc. Let's look at those on the number line. Okay, so 1, 2, 3, 4. And then we just added 0. Well, what about the other side of this number line? What's to the left of 0? -1, -2, -3, -4. Keep going negative, right? So what that very negative number, I don't know. What is the smallest number in the world? We could keep counting. So there is no such thing. So then we're going to go -3, -2, -1, 0, 1, 2, 3, 4, etc. So all of those numbers that we have on the number line here so far, these are all integers. They're the whole numbers and the negative whole numbers. Okay. So then rational numbers are all of these numbers, but also any number that can be written as a fraction. So any integer divided by another integer such that the denominator is not 0, because you can't divide by 0. That's not a rational number. So all of these numbers that we have here, all these integers, are rational numbers because they can be written over 1, right? So all integers are rational numbers, but then also fractions like 1/2 or 0.75, that can be written as a fraction. So that is a rational number. So any number that can be written as a fraction. So then if your number is not rational, it's irrational, in which case it cannot be written as a fraction. So that means these are decimals that never stop. So non-terminating. And they do not repeat. So I'll say non-repeating. And examples of that, everyone always thinks of pi. That's a number that is a decimal. It doesn't ever stop, and it doesn't repeat the same number. Another number is E. It's a constant number, 2.71, etc. The decimal places never stop, and they don't repeat. And one that you probably don't think of, but you probably do know, is the square root of non-perfect squares. So for example, square root of 2, square root of 5. Those are going to be irrational numbers in the calculator. There'll be decimals that go on forever. As opposed to something like square root of 4, which is 2, which is a rational number, integer, whole number, and natural number. So just the non-perfect squares, square roots, sorry, those are going to be irrational numbers. And so what are real numbers? All of the above. All the rational or irrational numbers are considered real, so everything on your number line. So fractions are rational numbers, and there are different rules for the operations of fractions. When multiplying, that's the easiest. You just multiply straight across. You make sure to cancel any factors that are in common between both the numerator and the denominator. So let's just go straight across here. Multiply 2 times 10 in the numerator, 5 times 3 in the denominator. And then if there are any factors that we can divide or cancel, we're going to do that. So like 10 is 5 times 2, right? So I could divide a factor of 5 between the numerator and the denominator. And so that leaves in the numerator 2 times 2 and the denominator just a 3. And that's fine as a improper fraction. We prefer those as opposed to mixed numbers. So when dividing fractions, you want to keep the first fraction the same and then multiply by the reciprocal of the divided fraction. And some people like to think of this as keep, change, flip. So you keep the first the same, you change division to multiplication, and then you multiply by the flip or reciprocal of that divided fraction. So now this is just multiplication. I'm going to multiply straight across. And if I have any factors in the numerator that are also in the denominator, I'm going to divide those. So 2 divides out, and that leaves 3 in the numerator, and 5 times 5, which is 25 in the denominator. When adding or subtracting fractions, different rules. You got to have a common denominator. And then you can just combine, which means add or subtract, the numerators over that same denominator. So if I want to subtract 10/3 from 2/5, I got to have the same denominator. So least common multiple of 5 and 3. And since they don't share any factors, that's just going to be the product of 5 times 3. Which is 15. So I need to get equivalent fractions with the same denominator of 15. So for 2/5, I have to multiply 5 times 3 to get 15. So I must multiply 3 to the numerator as well. Then I have an equivalent fraction of 6/15. For 10/3, I have to multiply by 5, so that's going to be 50/15. So let me rewrite this subtraction. 2/5 is 6/15 minus 10/3, which is 50/15. And now that I have the same denominator, I'm talking about 15ths, this difference is going to be 15ths. That stays the same. So then I just subtract the numerators. 6 minus 50 is going to be a negative 44. And 44 is 2 times 11. That doesn't have any factors in common. So that's going to be my simplified final difference here. Then we have the order of operations, which a lot of people like to think of as PEMDAS or GEMDAS, because P stands for parentheses. And it really just means any operations that are within a grouping symbol. So a grouping symbol is parentheses. It's also brackets. And we've got the set notation and absolute value. All of these are grouping symbols. So that will be done first. Look inside grouping, do operations inside of there in the order of exponents first, and then multiplication and division. You don't get to pick and choose, though. Multiplication and division must be done from left to right. And finally, addition and subtraction will be your last operations that you perform from left to right as well. So let's use this to simplify an expression here. If you have both a numerator and a denominator in your expression, then you're going to simplify them separately. So which one should we work on? Let's work on the denominator first. So I'm not going to change anything about the numerator. In the denominator, the order of operations, let's see. I have parentheses, but inside the parentheses, there's just a number. There's no operation. So in that case, the parentheses means multiply. So I'm going to multiply -1 times -1, and that's going to be a positive 1. I didn't change that negative. I don't change the negative sign in front, though, because that was already there. So next, in the denominator, we have subtraction. So -7 minus 1 is like -7 plus -1, and that's -8 altogether. Now that the denominator is simplified, I can work on the numerator. So I do have grouping in the numerator, parentheses there, and there is an operation. There's subtraction, -2 minus 3. So everything else stays the same. I'm going to do that subtraction inside of the grouping. A -2 plus -3 is -5 altogether. And then the last operation in the numerator is to add 5 and -5. Those are opposites or additive inverses. They add to 0. And 0 divided by any number is 0. In Chapter 2 of our textbook, this is all about linear equations. And so first we want to start with identifying what's an expression and what's an equation. So for number 1, x plus 8, that's an expression. How can I tell? There's no equal sign. For number 2, there's an equal sign, right? So that's an equation. And for number 3, there's no equal sign. That's an expression. It's important to know the difference between these two because equations have equal signs and you can solve for the variable that's in the equation. On the other hand, expressions do not have equal signs and you can only simplify expressions. You can't solve them. So like terms are terms that have exactly the same variables raised to exactly the same exponents, and terms are separated by addition and subtraction. So to combine like terms here, I have 4 terms in the first problem. And let's see if any of them have the same variable with the same exponent. So let me start with the highest exponent. There is no other term, so x squared, that's it. But then, when I go to the next highest exponent, x, there are 2 terms with that variable and that exponent. So I'm going to add the numbers in front, 2 plus 3. So that gets me 5 x's altogether. And then the last term is a constant term. It doesn't have any variable at all. For our second example here, we have 3 terms. And actually, the highest degree of the variable y is just y. So then I want to add the numbers in front, -2 plus 1/5. Unfortunately, those are fractions, so I need to get a common denominator, and that's going to be 5 because I can change a 1 into anything that I need to. So -2 is actually -10/5. So when I add those together, they're going to be fifths. -10 plus 1 is -9/5 y's altogether. And then the -1 doesn't have any like terms to combine with. So it stays the same. Then we have steps for solving a linear equation in one variable. Our first step is optional. You don't have to do this, but it helps. I usually like to do this myself because it makes it easier. You can clear any fractions or decimals as long as you have an equation, right? You can do pretty much whatever you want as long as you do the same thing to both sides. So you can multiply both sides of the equation to clear fractions or decimals. The second step is very required. If you have any parentheses, and then you can use the distributive property to remove the grouping. Third step, simplify each side by combining any like terms. Left side first and then right side. And then we can start moving terms from sides. So we're going to use the addition property to opposite terms so that we have number terms on one side and variable terms on the other side. Then we can get the variable to be the only factor on its side with the multiplication property by just multiplying the reciprocal of what is the coefficient of the variable to both sides. And then you want to check your answer to make sure that it's true. So our example here, there is a fraction, so we can clear the fraction if we want. I want to because I don't like fractions. So I'm going to multiply the reciprocal, which is 3, to that side because that's going to cancel that out. That's why I multiply by 3. But then I'm going to also multiply 3 to the other side because I have to stay equivalent and balanced. And be careful because there's more than one term on the right side, so you do need to multiply 3 to all terms on that side. Okay. So on the left side, 2 times x plus 6 equals the right side, 3 times x minus 5. And then we're going to use the distributive property to remove parentheses. So 2 times x is 2x, and 2 times 6 is 12. On the right side, 3 times x is 3x, and 3 times negative 5 is negative 15. Then I want to use the addition property because I don't have any like terms. So I'm going to start moving terms. I'm going to opposite 2x because that's the smaller coefficient of the variable. Then that'll leave just 12 on the left side and x minus 15 on the right. Then I want to opposite the number term from that side. So I'm going to add a positive 15 to both sides of the equation. That way I have just x on the right side and 27 on the left. And I don't need the multiplication property because I've already found the solution to the equation. And then if you just want to check by plugging that x in, so 27 plus x, and on the other side, and just make sure that it's true for both sides. So if we take that sum there, that's 33. 33 times 2 is 66. And then if you divide that by 3, that's 22. So that shows that we have the correct solution. In Chapter 5 of our textbook, there's information about exponents and polynomials. So there's a ton of exponent rules. I'm just going to briefly talk about them here. The first is the product rule. If you multiply a base by the same base, then you keep that base and you add the exponents together. Excuse me. And the quotient rule, quotient means divide. So if you have a base divided by the same base, you keep that base and you subtract the exponents. The power rule then is if you have a base raised to a power raised to another power, then you're going to multiply those exponents together. Then we have a power of a product. So say I have a product raised to a power, then each part of that product gets that power, each factor in that. And the same idea for the quotient. If I have a quotient raised to a power, then each part of the quotient gets that power, the numerator and the denominator. My favorite rule is the zero exponent rule. Any base raised to the zero exponent is 1. And finally, the negative exponent rule. If you have a base raised to a negative exponent, you're going to move that base over a division bar so that it can have a positive exponent. If you didn't have anything in the numerator, it'll be a 1. That's the coefficient. So that stays in the numerator. Let's use these rules to simplify some expressions here. Our first example, we have a quotient to a power. So the numerator is going to get this power of 2, and the denominator is going to get this power of 2. So that means Now we have products to a power, so each factor in the numerator gets that power. And each factor in the denominator gets that power. Okay. So in the numerator, 5 squared is 25. A to the 9th to the 2nd is a power rule. I'm going to multiply 9 times 2. That's 18. In the denominator, 10 squared is 100. And we have another power rule, so b to the 11 times 2 is 22. So we're almost done. I do have a factor in the numerator that's also in the denominator. I can divide 25 from both the top and the bottom because 100 is 25 times 4. So I'll divide the 25, and that leaves just 4 in the denominator and a 1 in the numerator, which I don't need to include because the 1 is understood. For number 2, I have separate terms separated by that addition symbol. So first term, let's simplify that. That's a power rule. We'll multiply 0 times 4. Second term, that's another power rule. I'll multiply 0 times 5. And now I have 0 exponent rule. 9 to the 0 is 1 plus z to the 0, which is 1. So 1 plus 1 is 2 altogether. That's the simplified expression there. For number 3, I've got some negative exponents, and I also have some quotients. I have the same base in the numerator and denominators. So I can use whichever rule I want first. I'm going to use the quotient rule, so I'm going to subtract the exponents for the base 3, and then subtract the exponents for the base 4, or base x, sorry. And so let's see, negative 1 minus 2 is negative 3, and 4, that becomes plus 7 by the general rule, so that's x to the 11th. Now I need to make sure I have positive exponents only. So x does have a positive exponent, it stays where it is. But the base 3 has a negative exponent, so I need to move that over a division bar so that it has a positive exponent. And then I can actually evaluate 3 to the 3rd. That's 3 times 3 times 3, which is 27. So that completes the simplification of that expression there. And lastly, we have some long division. This is in 5.6, and it follows a basic process of divide, multiply, subtract. That should be a different color. Should be a different color because this is the part most people forget. And finally, bring down. And then we repeat. So we go back to divide, multiply, subtract, bring down, and keep going until we don't have any more terms to bring down, and the divisor is a higher degree than the dividend. Yikes, what is divisor and what is dividend? You divide the dividend by the divisor. And so how you set that up is the divisor goes into the dividend. And these should be in descending order, like polynomials should usually be written. So we start with, how many times does x go into 5x squared? If we're not sure, we can divide. So that divides to 5x. I'm going to put that above the x term so that everything, lines up properly with its terms. And then multiply. So multiply by each term of the divisor. 5x times x is 5x squared. And 5x times 6 is 30x. I didn't write a plus sign because my next step is to subtract, which means I can just change those signs and combine these terms together. So that's going to leave me with negative 2x's. Then bring down the next term and start all over again. How many times does x go into negative 2x? That goes in negative 2 times, so line that up, and multiply by each term of the divisor. Negative 2 times x is negative 2x, and negative 2 times 6 is negative 12. Then I want to subtract, so change these negatives to positives and combine together. So that's going to leave me with a positive 2. There's no more terms to bring down, so I'm done. This is what we call the remainder, and how we write that is it's a positive 2 over the divisor of x plus 6. So, what's next now? We're going to complete the review for basic algebra homework number 1 and D2L from my math lab. And then we'll start working on module chapter 6.